Hello, my name is Maria Kasmirli. I'm a philosopher by training, but I've done lots of other things, including working at schools for many years. Today, I'm going to talk to you about teaching philosophy of mind to younger, pre-adolescent children. So let's do it. I think it's a very useful thing to teach younger children philosophy. It can be a preparation for formal study when they're older, in high school or university. But it has great value quite apart from that. Children find philosophical questions fascinating and enjoy discussing them. This activity helps them develop all sorts of really useful skills, which set them up for life, really. They learn to think about subjects carefully, to back up their views with reasons and supporting evidence, to listen to others' views with an open mind, and to give and accept constructive criticism in a friendly and helpful manner. All of this applies to teaching philosophy of mind too, of course. Children are naturally curious about what the mind is, how it works, whether their pets have got minds and what are these like, whether robots have minds, and so on. And they love talking about these topics. However, I think there is a problem in doing philosophy of mind and, in fact, of consciousness with younger children. The problem arises because of the way we do it, or rather, the way I think we should do it. I will explain what this way is and then say why it can be a problem for teaching philosophy of mind. In doing philosophy, the key thing is to get students to develop an open mind, to reflect on their own beliefs, attitudes, assumptions, to look at things from different perspectives, to compare these perspectives with their own, and to think about the advantages and disadvantages. This doesn't necessarily mean that we want them to change their original view. After exploring other perspectives, they may decide that their first view, their original view, was the best after all, and that's fine. But it does mean that they get to consider all the different options and the strengths and weaknesses of their own position. That's the important bit of it. Now, adopting other perspectives isn't always easy at least. All our experience has shaped us to take a view, and we're naturally inclined to defend and argue for that view and against the view of all the rival positions. So here is where I think imagination comes in. It may not be easy to accept other perspectives, but it can be quite easy and a great deal of fun to imagine them. So here's what I do. Instead of describing the philosophical positions in abstract terms, I create little scenarios, little situations for the children to act out. They have to imagine that they're a certain person in a certain situation with a certain problem. These scenarios are so designed that it's natural for the children, for the characters in them, to adopt a certain perspective or view, the one I want them to consider. Then I ask the children to act this out with as much feeling and energy as they can, so that they can identify with the characters they're playing. They enjoy this, of course, and I tell them that, I never expect them to have particular reactions or to adopt any particular view. I leave that up to the mechanics of the scenario and the children's imaginations. Then when they've done the exercise, We stop, sit down as ourselves again, and reflect on the trip we've had, on the imaginary situation. If it's worked, the children will now bring a new perspective to the discussion than they did before. And I call these the SIR method for the 3 phases: scenario, identification, and reflection. Now, in many areas, this works really well. Take ethics, for example. It is easy to create everyday, natural kind of situations which present different viewpoints and difficulties and challenge the children's pre-existing intuitions. Using these scenarios can help children appreciate a variety of different perspectives on the same problem. Then why do I say that this creates a problem for doing philosophy of mind? After all, philosophers of mind, and indeed of consciousness, use a lot of imaginative examples. They ask us to imagine what it is like to be a bat, to wonder what would happen when Mary leaves her black and white room, to conceive a creature that looks and acts just like us, but has no consciousness. So you might well think that my method would work just fine with this topic. The problem is that these scenarios are artificial, they're unnatural. When it comes to thinking about the mind, we do not have a sound basis of everyday intuitions to draw on, as we do with other areas of philosophy, as I said, ethics or politics, or even religion. And that is because the mind is a theoretical entity which we conceptualize through metaphors, as a computer, say. And the thought experiments we use often serve to create intuitions rather than to test them. In fact, they're often specifically designed to induce a particular impression, to create a particular intuition. They are what Daniel Dennett calls intuition pumps. Imagining what it is like to be a bat is designed to pump the intuition that is something very special and very private about the bat's inner life that science will never be able to capture. Similarly with Mary and the zombies and all the other examples. The computer analogy, of course, goes somewhat the opposite way. That it's designed to pump the intuition that the mind is a machine. These imaginative experiments do the opposite of what I'm trying to do. Instead of opening up new perspectives and challenging existing assumptions, they create a view on a topic that the students may have never thought about and fix that view in the mind of the student as one that is compelling and undeniable. The result of this is that by introducing children to these metaphors, we can end up inadvertently installing in their heads a certain theory of what the mind is, which they find very hard to criticize or move beyond. In short, the very method that can work to open up kids' minds in other areas, to help them think in a very open-minded way, can work to close it down in philosophy of consciousness. What shall we do about this? Should we avoid metaphors and intuition pumps and focus on introducing scientific findings about the mind? I think we should introduce children to science, yes, and I'll explain how I do it in a minute. But that will be very hard for children and perhaps even limiting. And in any case, there are some people who believe that science will never be able to help us understand the mind fully. But apart from that, we need metaphors and analogies. The mind, the brain, is an immensely complex system and it's very hard to understand its operations in detail. For everyday purposes at least, then, we need convenient, user-friendly examples, ways of conceptualizing what our minds are and how they work. Another option would be to say that perhaps we shouldn't try to do philosophy of consciousness with children. Then that way, we wouldn't do any harm. I don't think that's a good idea. Children will encounter ways of thinking about the mind offered by other means, religion, pop psychology, their own imaginations. So they'll inevitably come to think about the subject, and we want them to have the right tools to do it really well. Here's what I suggest. I propose we use the imagination-based method I recommended, but in a more student-centered way. Instead of presenting children with standard scenarios and thought experiments, we ask them to brainstorm. We ask them to come up with imaginative ways about what the mind is and how it works, about what seeing, hearing, feeling, thinking, and consciousness are, using as far as possible common everyday language. They may draw pictures, diagrams, suggest comparisons, or even propose original scientific theories. It doesn't really matter too much about what their suggestions are. They may even be fanciful. They may wonder if there are little people inside our heads like numbskulls, whether there's a soul that operates and does everything in my head, whether the mind is like some kind of fanciful clockwork or like a laptop computer. Children enjoy this, and they come up with all sorts of wonderful ideas and unexpected comparisons. One of my students suggested the mind is like a factory, which is operating when we're awake and closes down when we go to sleep. He even said that people are in a coma because the workers have gone on a strike. As I said, the initial ideas themselves do not matter too much. The important bit comes next. The next step is to get students to reflect and evaluate each other's suggestions. Is this a good image of the mind? What does it get right? What does it get wrong? Is it misleading? Is it helpful? Is it useful? Of course, the students are still going to draw on their intuitions in the process of assessing suggestions. But we're not pushing those intuitions in any one direction. That's the crucial bit. And more importantly, we're encouraging them to take a critical attitude to these metaphors, images, analogies, thought experiments, and theories in the area. We want them to realize that it's a matter for discussion, what the right image is, what the right metaphor is, what are the right questions to ask, and what options should be considered. In short, we want them not to just imagine different answers to the problems of the mind, but to imagine different conceptions of what the problems are. The final step is to add new information to the mix. This is where I think we can use science. After a round of brainstorming and evaluation, the teacher provides some basic information about the mind drawn from biology, psychology, neuroscience, behavioral science, and things like how do the nerve cells work, or how the attention and limits of visual experience work, about the overall structure of the mind. The children think about this information, and then they have another round of brainstorming and another round followed by another round of evaluation and critical kind of assessment, and so on. You repeat this as many times as you need to. So I'm suggesting then that with younger children, we should avoid traditional examples and thought experiments and adopt a 3-stage process of brainstorming, peer evaluation, and information acquisition. The teacher will explain the aim of the process and say that it's to find a useful but very simplified model of an extremely complex system. Then hopefully, when the students later encounter the ideas of professional philosophers, they'll see the connection with what they used to do in their very first philosophy of mind classes. They'll see that philosophers of mind are offering also very simplified models designed to reconcile our everyday intuitions with what the science tells us about the nature of us as biological systems. With luck then, our students will come to take a more critical view of the way the problems are framed and thought experiments are used. So instead of asking, what is it like to be a bat? They may ask, what can we know about what it is like to be a bat? Instead of asking what Mary learns when she leaves her black and white room, we may focus on what she learns when she's still inside that room. And when it comes to hard and easy problems of consciousness, we may ask whether those labels really are the right ones for the problems in question. So that's the theory behind my approach. How do we put it into practice? What sort of materials do we use to stimulate children's imaginations without imposing a particular vision upon them? The original idea was for this to be a live workshop, and this would have been the point where I would have been opening up the session for people to come up with ideas, discussion, and practical suggestions, or suggestions for further investigation, really. It's not live, but I would still like to hand it over to you, and I hope that at some point we will be able to have this discussion, albeit in a different form. Thank you very much for listening.
Good morning. My name is Donna Thomas and I'm a research fellow at the University of Central Lancashire, and I work in a research centre called the Centre for Children and Young People's Participation. And as a centre, we do a lot of work with children and young people at an international and national level. So we work with the Council of Europe, for example, researching and advocating children's rights. And we get commissioned off different organisations to explore different areas of social life with children and young people. And for the next 20 minutes, I wanted to talk about an area of our work, which is exploring the nature of self, experience and reality with children and young people. So I'm going to talk about why this work is important with children and young people, and think about where we are now in social sciences in terms of epistemology and ontology, and thinking about what we think about self currently, and what reality is and the implications that has at the moment in terms of supporting children and young people, and especially children and young people that are in crisis. And that is very much on the increase at the moment, especially in the Western societies and particularly in the UK as well. To try and exemplify this, I will discuss a pilot study that we've just completed that goes to children and young people themselves to start to explore questions around the nature of self, looking at what kinds of experiences children and young people are having and what that can reveal really about the nature of self and reality. So I'll talk a little bit about that, a bit around the methodology, but more importantly trying to focus on some of the initial findings that's come out of that now, and then discuss some of the next steps and where this work is going on a more international level as well. So why is it important that we explore with children and young people the nature of self, experience and reality? Well, there are lots of reasons why this is really important. first of all, in social science, and particularly in social science research, we meet people from an assumption about what we are as human beings. And this has huge implications for how we provide services and support, not just children and young people, but adults as well, because it is a social science issue, but we're specifically talking about children and young people here. And children and young people are often absent from studies of this kind, anything that's related to consciousness studies or research concerned with non-conventional experiences, transformational experiences. They're absent from that, and there's lots of reasons for that. There's some arguments around children's egos aren't developed enough to look at that, or they're not reliable research informants, which we could very much argue these points, but we don't have time here. So it's important because children and young people are having, they're experiencing the world in quite different ways and almost rebelling against these systems that we have in place at the moment, these systems that are very much in crisis as well. And there's a real ordinariness at the moment to a spectrum of non-ordinary experiences that children and young people are having, and we don't capture them in social science and social research. We very much value the idea of policy-driven experiences that kind of position children and young people into a conceptual self, and we'll talk about that as we go along as well. It's important because it's about developing a set of different kinds of research methods. It's about having the courage to do research differently. And when we do research with children and young people, we are inclined to use non-traditional research methods, which might be art, it may be play, it may be music, but it's those methods that kind of access deeper levels of self and bring out that creativity. And it's what can children teach us about that, and how can those methods be applied to exploring the nature of self and reality with children and young people. As the work moves forward, and I'll talk briefly about this at the end, it's very important to look at how adults in authority are responding to how children experience their self and others and the world, because there are implications at the moment for adults who also have quite a mainstream view of self and reality that are responding to children and people in particular ways that could be catalysing more suffering that's actually necessary. And for us to be able to look at what that means on a global level and consider different social cultural responses to very similar kinds of experiences, it is a big an important part of this work as well. So it's really valuable to look at where we are now in terms of, in social science, how we understand self, and where we might need to go to for this to be more meaningful, for not just for children and young people, but for adults as well. But in 1934, Herbert Mead, he published Mind, Society and Self, and it was quite radical at the time because most of his contemporaries approached the idea of self as very biological, a brain in a body, and anything about that was down to what we inherit from our parents and grandparents. But what Mead proposed was the idea that self wasn't really like that, and it was very emergent, very transient, but it was held in a relationship to a pre-existing world outside of itself, so a world of things and objects. And sadly, this hasn't really changed that much. Maybe it's changing a little more on an academic level, but certainly in practice, in social research with people, we've not moved away from these ideas whatsoever, and this is having implications as well. And there's lots of turns in social sciences. So instead of looking at the ontology of what is the nature of reality, we stay with these old assumptions and quite worn out assumptions, and we just build theory on top. And we're left with all these turns in social science, whether it's narrative, postmodern, reflexive, posthuman, but each turn positions self and reality in a particular way, and we all tend to come at it from all these different angles. So there's multiple genealogies around the self in social science as well. The most recent term is post-human, and this has been very useful in kind of decentering the idea of a mind-body-I or a mind-body self, and really brings in the idea that we're very connected to everything around us and in our field, so the universe, the stars, material objects and other people. But what it doesn't do is really give us that idea of self or subjectivity or agency. It's a very, very flat ontology. There is no reality. There's just assemblage of things that are coming together and dispersing in every moment. But in social science, self and subjectivity, and particularly agency, is really important. It's the idea of needing to retain that kind of diverse and wonderful idea of individuality, and people really being able to express experiences on that level in order to create change, and reconciling that with a bigger picture almost of, well, actually self may be much more than this mind, body, I. But it's been good in moving away from that postmodern idea of individuality. And in social science, lived experience is a massive thing as well, but that's also questionable, because in social research, that lived experience always comes from the story I or the conceptual I, and we don't really take it any further than that. But story eyes and conceptual eyes can be very deeply conditioned from political, social and cultural forces, and it doesn't tend to be unpicked. We take that truth and that knowledge from that kind of surface level idea of self. But what's interesting is that in other scholarships, such as consciousness studies and quantum physics, they're really offering new possibilities of not just the nature of reality, but what self could mean, and what the eye of experience is. So this work is very much about kind of harnessing that and thinking about how can we bring that into social sciences, and especially when we're researching with people, but how can we bring children and young people into these areas of scholarship to inform how their ideas of ontology are developing. So we have people like Bernardo Kastrup, who kind of posits this consciousness only model where people are alters or expressions, localizations of a consciousness that is the ground of being, and people like Philip Goff, who look at panpsychism and suggest that kind of subject combination idea that each little thing it has consciousness. And then we have someone like Bellman's who has this dual monist approach and talks about, well, consciousness could be the ground, but there's all these other things to consider. And it's thinking about, how can we bring these ideas in to have a more meaningful and a more powerful explanatory framework of reality that can really support children and young people and adults too in social science research. So we decided instead to keep looking at the theory and ontology and epistemology to go directly to children and young people themselves. And we did this through a pilot study called Who Am I? Exploring the Nature of Self, Reality, Experiencing Reality with Children and Young People. And this was a small, very deep, very qualitative study that worked with 10 children and young people and using very innovative and interdisciplinary creative research methods in a very slow and deep way with children and young people. And I don't have time to talk about the methodology in this presentation, but please contact me if you do want more information about the methodology. My contact details will be at the end. But we did use self-inquiry techniques, art, dance, movement, mandala making, along with also narrative as well, to try and capture those kind of different expressions of self as well. And in terms of the findings, we focused on three things really. The first was self. So it was trying to get an understanding with children about the nature of self to the best that we can, because it is a very tricky and slippery thing, as you're all probably aware. And we also wanted to capture the spectrum of experiences that children and young people were having, which I'll talk about in the next slide. But also importantly, to kind of listen to and understand children and young people's ideas about the nature of reality, from their own perceptions, but more importantly, from their own experiences as well, which I do talk about as we go along. But just first of all, starting with self, just to bring your attention to the diagram. And, just to reinforce that it's extremely difficult. The job that we had to try and even talk about this in any kind of way was extremely difficult as well. We started the research by asking a simple question: can you tell me a bit about yourself? And of course, that when we ask, we're all, as human beings, we're natural storytellers, and we will tell a story, quite a default position, and that's what happened with children and young people. So the first level of self, and I'm using the word level really crudely, we identified the conceptual I, and this was kind of the story I, and this is where children talked about, their self as name and age, and this is where you find conceptual objects such as hobbies and passions and things that were going on, and the me and the mineness was here, and that's why I've put possession there. So things were mine, including people as well. And on this level of self, a real diverse and beautiful expression of differences. So every child and young person just had this wonderful, wonderful individuality on this level as well. And quickly moving on, as children and young people began to share what we term non-conventional experiences, and these are experiences that could be peak or transformational, they could be speaking with dead grandparents, it could be having premonitions, and I'm going to talk about that more on the next slide. We found that children and young people, there was kind of an epistemic shift at this point, and how they talked about this became more difficult. So as they moved out of the conceptual I, language became, it wasn't sufficient for them to be able to relay these more non-conventional experiences, and that's when the art and the other methods came into play at this point. And the transpersonal I was more feeling, intuition, metaphor and imagery to try and convey their experiences, descriptions of time really slowing down, so a different perception and experience of time, and non-linearity. So with the conceptual I and the storytelling, there's this linear idea or this linear perception of this happened and this happened and this happened, this is who I am, and then that and then that. But when we move to the transpersonal I, it's very spatial. There isn't really any linearity to that, and especially again when they're talking about these non-conventional experiences. And then as we started to do and facilitate the self-inquiry methods with children and young people, silence became very kind of prolific. It became very loud almost, and children would fall into a silence that I started to term as kind of an epistemic bridge between these senses of self almost. And children couldn't really relay their experience at this level of I, at this level of self. The best was they began to kind of try to work with mandala, which was extremely difficult, and they're still doing that at the moment. Non-verbal, no words. The best we had with verbal was I don't know, or it's just unknowing. It's unknowing, which led us to this idea of it seemed to be a knowing element that was present across all their experiences that couldn't really be verbalized, that had a sameness to it. So where we had this difference and diversity of the conceptual I, when we come down to what we call the knowing I, or that knowing element of experience, it was the same for each child and young person despite their conceptual differences at that level. And I realise I'm quickly running through this because I want to talk about some of the findings as well. These two pictures they come from the study, represent this kind of transpersonal I. And this one here, this was a 16-year-old girl who was trying to convey her experience of having some kind of empathic abilities, and she said this was her in the middle, and her in the middle, the transpersonal I, was a combination of this person, her friend, and herself at the conceptual level. So she was trying to express that here. And this drawing is from a little boy who's 8 years old, who sees himself more here at the level, a light body with this knowing I, which actually looks like an I, which is really interesting. And your soul is you. And interestingly, that this little boy, he comes from a very secular background, so this word was quite interesting here. So just rushing through now, when we asked children and young people why they joined the study, that was the key question to enable them to start to talk about any kind of non-conventional experiences that they'd had. We had so many examples of what we'd call non-conventional experience. So we have children and young people who talk to dead grandparents. There is sleep paralysis, there is lucid dreaming, there are premonitions, there are unseen beings, which can take the form of human beings or beings out of this world, or animals. Animals featured largely with children and young people. Transformational experiences in nature where a sense of self is completely dropped, and children and young people have found themselves, their idea of self, as being one with the world, everyone else, and the universe as well. So we had a vast range of different experiences from children and young people. And this picture was drawn by a 17-year-old girl. She has quite a long backstory, but she was hearing helpful voices and she couldn't convey this very well. And the image tries to represent the idea of a tunnel and time slowing down, and a chorus of similar, what she describes as robotic voices. But then when we unpicked that, it meant more that they were very slow, so time was slowing down here. But what the study captured was the reactions and responses of adults in authority, and adults in authority can be teachers, more often than not parents, which is quite interesting, and of course professionals, because some of these children and young people do access services as well, and it seems to be the same thing. An example is, you've done that, you've got schizophrenia, let's get you to the doctor, you need medication. So there's a real pattern here of a knee-jerk response that adults in authority don't seem to have that understanding or that kind of open-mindedness to actually exploring with children, well, what does this mean? It's straight away to the kind of mainstream idea view of you're unwell, disordered, or it's not real, so you're silenced as well. So that came out of the research quite heavily. And we do have children in crisis. We have a huge crisis at the minute, and this is mirrored in the response that what we're doing on a social level. A GP diagnosis, somewhere like CAMHS, and medicated, and at the very worst incarcerated. So this is why this work is so important, to start to explore with children and young people what these experiences mean, and what can they reveal about who we are and what we are as human beings, which is the crux of the research as well. So children had some really quite interesting views about the nature of reality, and really expressed that in quite a no-nonsense way as well. And these views probably come from a mixture of pop culture, a mixture of family influences, but more often than not from their own direct experiences, and especially for these children who have had an array of non-conventional and transformational experiences. But just to give you some examples, reality is that we're all one, we're all connected. There's kind of a God that's holding everybody, holding the world and the universe, and I'm referring to the picture here. No gender, no face, because it's not really a person. And some young people, well, it's a hologram, so it's like when you kind of die in a video game and you get rebooted, or I can't remember the actual term for it, but some really interesting. And when we think about what's coming out of quantum physics or consciousness studies, the scientists are pretty much saying the same thing. So it's how do we kind of reconcile and match these experiences with what's coming out of these other disciplines as well. So just to summarise, there is really a need to reconsider what self is and what it means to be human in social science, and particularly in social research with people, so that we can really inform in a more meaningful way how we can be together as a society, but also support people who do need support, especially at the moment as well. We need to return to the questions about the nature of reality instead of to keep building on these assumptions, which is what we tend to do in social sciences. And we need to do this in a very interdisciplinary way. We need to also think about experience and be more inclusive in social science about the types of experiences that we value and that we listen to and not dismiss, and look at what experience can tell us actually about the nature of self, because many of the experiences that have come up in this study start to really think about self as not being in the body and not being in the mind, but mind almost being non-local, and children having access almost to kind of different versions of reality, or there's something going on that's pointing to the idea that we're not a self in a mind, in a body, in a brain. It seems to be much more than that, and that's really important. The role of children in this are extremely important, and we need to start to consider children more as a good source of authority, reliable and competent researchers, and as they're showing, competent philosophers as well. And we also need to consider the holistic approach in terms of families and adults, because how adults and parents especially are responding to children and young people is having huge implications for their suffering and crisis. So it tends to need a holistic approach. And just to finish really quickly, the next steps for this is we are currently applying for a substantial research grant to enable this pilot study to be more of a global international study, so we can really capture other cultures and how adults and the communities and cultures are responding to similar sets of experiences that children in the West are having, and what can that teach us almost in the West about how we can start to respond to children and how they're experiencing self, others and the world. And already we have a lot of interest in this work and some fantastic people who are coming on board. It is interdisciplinary, and as a social scientist, it's about getting help from experts in other fields such as maybe transpersonal psychology, quantum physics, particularly philosophy, and consciousness studies as well. And already we're having that support around the work, which is just absolutely wonderful. The next stage is we're bringing children in as researchers, so children who have been part of this study will come do some of the research training and really inform the design, particularly the methodology, and in what ways we can approach especially self-inquiry in a more meaningful way with children and young people as well. So if you are interested in the work, or I'm sorry I didn't have a chance to talk more about the methodology, for example, please do contact me. It'd be lovely to talk about the work and get some of your opinions and views on this as well. And thank you so much for your time. Thank you for listening or watching. Thank you.
Hi, my name is Scott Koshland, and I'm an independent researcher from Coronado, California. The title of my poster is Application of the Principles of Learning Theory to the Organization and Development of Living Systems, Life, and Consciousness.
Let's start with a general overview. First, we will look at information and defining what information is. Then, we will look at how information is transformed by information processors. Then, we will look at how the information processors link together to form hierarchical systems and networks. These network systems can organize in such a way to form emergent systems. We will then look at how the formation of knowledge, learning, occurs in a learning cycle of inductive and deductive learning processes. Next, we will look at life and consciousness in terms of this information learning cycle and the formation of emergent information states. These emergent information states result in cognitive operations and functions of an organism. These emergent cognitive functions and operations translate into the functional behavior of the organism. We need to define life in terms of information. Life is an integrated, intelligence-sustaining behavioral system. All living systems, all life, individually and collectively, display a level of intelligent behavior in their formation and actions. This intelligent behavior is the ability to perceive or infer information and retain it as knowledge to be applied towards adaptive behaviors within a contextual situation. Intelligence is operating with a memory, a logic process, with understanding, reasoning, planning, creativity, and adaptation. Information. Information is a term that we use for characterizing and defining everything. So when we ask what is an atom, we define and characterize the atom by information. It is not to say that the atom is information, just that we define the atom by information. The Shannon theory relates information to the probability of something occurring, stating that the less likely something is to occur can have more information, while something more likely to occur would have less information. This relates information to entropy. And of course, in the information age, we can use bits and bytes to encode information.
Okay, so let's define information processing. Information processing is a transformation of information. And so it's basically taking some input information and it's transforming that input into output. So that information processing can be described mathematically by set theory or in geometrical terms. It's essentially a function or an operation. From the information pyramid, we see data that forms information that forms a higher knowledge. And essentially that knowledge is an information, it's a function or an operation that forms the data, so from input to output. So we can define these information processing systems that are transforming information, taking information from input to output. Then these information processing systems can form networks, forming linkages that form networks that are organized in a certain way, and they're communicating input to output back and forth. And then those networks can also form hierarchical networks, where a higher network is over a lower network, determining the activity of the lower network. Okay, so the next term is emergence. Emergence is a system hierarchical function process that results from component system organization that differs from the component system processes. So a good example of this is basically where a system components of information processors come together, organized in a certain manner, and then they form a higher emergent system. And that emergent system is doing activity that's not like what the components are doing, and so it's a different operation at a different level. And so the best example of that would be that, basically would be us, the humans, is that our cells all come together, organized in a certain way, certain networks, and those form an emergent system that is us, and we interact with our environment differently than what our cells interact with. So the emergent system activity is defined at the emergent level of interaction. The emergent level will process information in a different manner, operation or principle, than does the components which are derived at a lower level. So basically just saying there's a different operation at this emergent level, and that the interactions are determined at that emergent level, not at the lower level. So in other words, we're interacting with other people, our cells aren't interacting with another person. Now, so emergent systems are top-down deductive hierarchical processors that are formed in a bottom-up inductive process. Again, and this is basically our cells coming together inductively, forming it into our emergent system, and then the emergent system is our interactions at our level are determining the activity of the cells at the lower level. And these emergent systems can be kind of looked at as a homeostatic system, so in controlling these lower component emergent systems.
Learning is the information system transformation and organization and the formation of knowledge. The information pyramid relates data, information forming into knowledge. This knowledge is an information processor that converts input into output. There are two processes for this learning. First is the inductive empirical learning, which is a bottom-up experiential process involving an individual in real-time making of decisions that create a pathway of learning. The second learning form is deductive principle determination learning, which involves a top-down determination of learning. The deductive learning is not determined in present time and can be determined by collective learning, creating an instinct or memory at the higher level of interaction that determines decisions and activity at a lower level of activity. The inductive-deductive learning cycle. Learning occurs in an inductive and deductive cycle of forming knowledge. The inductive learning occurs in a novel experiential situation, bottom up, creating decisions that result in higher level interactions. These inductive decisions interact and are assimilated at the hierarchical level network operation and function that deductively determine the lower hierarchical level organization and activity, thus creating a memory or instinct. The lower level collective memory is then assimilated into the basis of the individual's inductive learning process in a new situation, repeating the inductive-deductive learning cycle. Let's look at life as an intelligent behavioral system in terms of information organization and system learning. Intelligence is operating with a memory, a logic process with understanding, reasoning, planning, creativity, and adaptation. All life has memory. Memory is the stable, stored, retrievable information. Whether this information is stored in DNA, protein, or is a memory of what you did yesterday, it's all life has memory. This is important to distinguish life from non-life. The living system, intelligent system information learning is divided into these forms. The living system has both individual and collective learning. We can distinguish and consider the individual learning process and the collective learning of an organism. This would be like a bird that learns a particular behavior, then this behavior can be imprinted into the collective instincts of all those birds. There are also conscious in-time decisions and unconscious out-of-time determined decisions. There's the inductive and deductive learning cycle that we talked about. And also this learning cycle creates networks that form into distinct hierarchical emergent learning cognitive operations and functions.
Okay, so life, intelligent information organization and process. The intelligent information processing is translated into three levels. There's information processing, organization, forming emergent states. Okay, so that's what I was just saying, is that you can look at the information and how that information is accumulating, goes to an emergent state. Again, an emergent state is it's based on component interactions that create this emergent state that are doing operations that are different than the component interactions. And then those emergent that information processing and those emergent states can be translated into cognitive functions and operations of the organism. So not looking at just in terms of information, but now looking at what are those cognitive operations and functions from a standpoint of what they're actually doing. And then those cognitive functions and operations are translated into actual behavioral activity of the organism.
The information organization of life can be considered in the following terms. The first is the individual in making in-time decisions, and then collective out-of-time processing and memory, where the individual is making in-time conscious decisions, and then the collective having out-of-time determinations and memories. The individual makes decisions in real time, and then there are out-of-time decisions creating determinations, memories, and collective instincts. Then there are the inductive, deductive learning cycle process, organizing information, network systems, forming knowledge, and creating memories and instincts. This information learning process creates hierarchical emergent state processes and operations that have emergent functions for the organism's intelligent information system structure. There's also an emergent point between the individual and collective systems that allow for the balance and synchronization between these two systems that allow for transition to the next emergent state. If not in balance, then the system will continue processing at the emergent state until synchronization is achieved. Cognitive functions and operations. In humans, the information learning cycle process forms 7 emergent operations that define the progression of intelligent learning. These are cognitive emergent operations that represent a logical progression of the learning process from a most basic processing of information to a very abstract and complex ability. Each emergent operation represents a type of cognitive process for transforming information in an intelligent progression. Each emergent operation has an associated underlying function for the learning process. The most basic cognitive emergent operation is concrete memory and recall. This is the fundamental operation of an ability for the function of survival, allowing for basic rote operation of direct association of concrete processing of memory and recall. The next emergent operation involves comprehension, understanding, and interpretation of information that allows for the greater ability in the formulation of decisions and learning. The comprehension operation translates into the function of propagation. The propagation function involves promoting and expanding the survival function. The next emergent operation involves the application, implementation, and utilization of the comprehension operations. This implementation operation corresponds to a transformative ability function, utilizing the comprehension operation to generate transformation. This relates to directing transformative ability to achieve propagation and survival. The next emergent level operation is analysis, inspection, and examination, where the processing of knowledge and its application are examined and analyzed into their basic constituents or structures. This analytical operation corresponds to defining a functional motivation for the cognitive decision learning process, directing the transformative ability. The next cognitive emergent level of operation is evaluation, assessment, and appraisal of the analyzed and examined information. In this operation, information is appraised. This appraisal cognitive emergent operation corresponds to determining a functional coherence for the underlying motivational functions. The next cognitive emergent operation is synthesis and development, combining ideas and knowledge to form complex understanding. The synthesis emergent cognitive operation corresponds to functional wisdom, taking the coherent, derived functional knowledge and developing an optimum understanding. The highest cognitive emergent level operation is conception, innovation, and formulation of new knowledge. In this highest level operation, completely new concepts and understanding are generated, built upon the underlying synthesis operations. This highest level cognitive conceptual operation corresponds to transcendent functions that build upon the wisdom function to create the highest level of knowledge and conceptualization. Behavioral activity. The emergent cognitive operations and their underlying associated emergent functions translate into emergent behavior. Each emergent behavior level is divided into individual and collective focused behavior. These individual collective associated behaviors determine the overall composite behavioral activity. If an emergent level behavior is out of balance at one or the other individual or collective focus, then that will be the dominant behavior driver expressed. If these are in balance at a given emergent behavioral level, then the next emergent level behavior comes into expression. The first emergent behavior is intent, related to the basic survival cognitive function. In this survival intent behavior, the extremes of individual behavior are greed, wanting all for oneself, and the opposite collective extreme is generosity, giving all away. The next emergent cognitive function is propagation, which translates to inspiration behavior relating to incentive derived from the underlying understanding of the survival function. The individual behavior extremes at this level is gluttony, insatiability, and the collective extreme is temperance. The next emergent cognitive function is transformation, which translates into forbearance, relating to the self-control of the transformative and applicative abilities. The individual extreme is sloth, and collective extreme is diligence at this level. The next emergent cognitive function is motivation that directs activity, which translates into the emergent behavior of love. The individual extreme at this level is lust, and the collective extreme is devotion. The next emergent cognitive function is coherence, which translates into behavioral truthfulness. The individual extreme at this level is wrath, and the collective extreme at this level is tranquility. Wisdom is the next cognitive emergent function, which translates into vision, the ability to act anticipating that which will come about. At this level, the individual extreme is envy, and the collective extreme is gratitude. The highest cognitive function is transcendence, which translates into transcendent behavior. The individual extreme at this level is pride, and the collective extreme at this level is humility. So in summary, we've looked at the underlying developmental process of life and consciousness have been defined in terms of information system organization and learning. We looked at information processing, system organization of networks and hierarchies, emergent systems, the learning cycle in terms of the inductive processes, life and consciousness, cognitive operations and functional information processing, and translating into functional behavior. So in conclusion, life is an integrated intelligent behavioral system that can be defined in terms of information system learning. Thank you very much. Any questions or comments, please send to scottkoshland830@gmail.com. I'd like to make acknowledgments to the very special work of George F. R. Ellis, Rupert Sheldrake, Simon Conway Morris, Leonard Siskin, Bob Doyle, Max Tegmark, and Seth Lloyd.
Hello everyone, my name is Anton Sukhoverkhov. I am from Kuban State Agrarian University, and I would like to share with you why we need to explain the origin of human nature by means of social memory and non-genetic inheritance. Here some of my research interests. I like to study biosemiotics, philosophy of language, and different theories and extended evolutionary synthesis. And let's go straight to the point. I think that there are two main approaches to the origin of human nature. I call them bottom-up and top-down approaches. Bottom-up approach believes that human beings and their unique cognitive abilities originate from internal changes, for example, genetic mutations. Top-down approach thinks that human nature requires external factors. It depends on and mediated by society. A newborn child needs external social, ecological scaffoldings to become human, like chick needs hens incubation to hatch. So bottom-up approach states that we need a biological human hardware to have a human nature. So for example, if we have a bigger brain, we will have a better cognition and more advanced language, and no brain, no human nature. So a biological hardware is first, and society, environments are second. Top-down approach would say, sorry, but is hardware enough? For example, if we take a feral or wild children, they have a brain that's similar to all human beings, but they don't have a human nature because they wasn't surrounded by human society and they acquired only animal behavior. And so that's why top-down approach would say that we need a social software to become human. Society provides this software. The better is developed society, the better is developed human nature. Therefore, human nature is nested in society, not in biological nature, not in brain or not in genes. But if human nature is not inherited genetically, then how? In accordance with extended evolutionary synthesis, by means of non-genetic or epigenetic inheritance or social memory. For example, if Jablonka and Marion Lamb, they introduced idea of epigenetic, behavioral, and symbolic inheritance together with genetic one. Odlin Smith and his colleague also insisted on ecological inheritance. For example, ecological niches, social niches that scaffold human development and animal development. So these approaches, this non-genetic theories, non-genetic inheritance theories, they show that we have not only individual physiological traits, biological and social system, they have a system traits that can be passed by non-genetic mechanism of inheritance, and they help to adapt to environment by means of organizational evolution and adaptation. Therefore, top-down approach would say that human nature is a system trait transmitted by behavioral or social inheritance. For example, we teach our children how to walk in upright position, or we teach them how to be a boy or girl, and sometimes we are trying to pass our traits, cultural traits, social traits, to our closest relatives, apes, and other animals. However, whatever position we choose, we still have a paradox of the human nature origin. It's similar with a paradox which came first, the chicken or the egg. Indeed, to become human, we need society. However, the origin of society presupposes the origin of individuals with a human nature. So question is, which came first, society or individuals with a human nature? The similar paradox we can find in the language origin. Because, for example, if one person has a genetic mutation that gives him or her ability to speak, does it mean that everyone will get it and this language will spread in society? Actually, not. Therefore, problem is how to introduce a language without any language to a person that has no idea about language. We need for this natural language or conventional language. If we have just natural language, it should be before we have some kind of genetic mutation for creation of conventional language. So to solve this paradox, human nature and origin of language, I think we need to shift from individual approach to evolution to system and dynamic approach. We should consider evolution as evolution of system, not just individuals. And my main thesis is that human nature and language are emergent system traits, irreducible to genes or physiological properties of particular individual. For example, in universal symbiogenesis theory, in theory of superorganism and development system theory, we can see that adaptation to environment happens not only through the biological adaptation, biological plasticity, and biological traits, but through system adaptation, traits, and plasticity. For example, well-studied quorum sensing show us that bacteria can communicate with each other when they have a proper amount of bacteria in an environment. And this language emerged spontaneously without any agreement. So it's kind of a system property that emerge without any preliminary preparations. And for example, and I think that human nature is also such an emergent property that originates in system interaction. For example, like ants that create bridge between two trees. This bridge is emergent property of ants, and it can be reduced to individual ants. All these penguins that created circle to make a better condition for the chick in the center. It's kind of social thermoregulation, and it's also social trait or system trait that created in environments for adaptation, for better adaptation. And furthermore, I should say that human nature is not just interaction. Let's take as example the University of Arizona. University cannot be reduced to particular individuals or particular buildings. The university is a system with a distributed cognition, with distributed and shared memory, and with extended cognition, extended regulation. So this university will last longer than particular individuals that form this university. And from that point, university is an informational system. It's a kind of software, not just hardware. And university also scaffolds development of individuals in accordance with the requirements of society or requirements of business and economics. It proposes to student particular individuality, particular role in society. And that's why I think that human nature is not located in individuals, as well as language is not located in some part of the brain. Human nature is a system trait, socially distributed and inherited non-genetically. And I would like to finish my presentation with a quote from McElroy's article, The Coevolution of Genes, Innovation and Culture. He stated that much of the knowledge that most farmers employ to manage wheat accumulated over many generations, but it is not contained in anyone's genome. No individual in the course of his or her lifetime could accumulate it. So my point is that human nature indeed is not contained in anyone's genome, and it is accumulated over many generations in society. And I think we need to accumulate various achievements of good human nature, and we should pass this tradition to the next generation. And it would help us and society to develop and to prosper. And at the end, I would like to express my gratitude to my colleagues and supervisors who helped me with this research. Thanks to Mikhail Ilyin, Ruth Millikan, Carol Fowler, Carol Stotz, and Vladislav Lektorsky for their help and assistance in my studies and my research. Thank you, everyone.